Balancing simple redox reactions. So what we're looking at is making sure that the number of electron transferred is constant. So here I have a reduction reaction and an oxidation reaction. My lithium is the oxidation reaction because it's losing electrons. Oil oxidation is lost. And sulfur is gaining those 2 electrons. So lithium loses the electron to become a +1 charge. Sulfur gains 2 electrons to become a -2 charge. Because sulfur needs to gain 2 electrons, I have to multiply this reaction by 2 so that the electrons that are needed by sulfur are the ones that are lost by lithium. So this would then result in the balanced equation 2 lithium plus sulfur yields sulfur -2 and 2 lithiums. So you can either do it this way or you can do what's called by half method. So you're saying, all right, going from a 0 oxidation state to -2, and it's 0 because the overall charge here is 0. I'm going to have to gain 2 electrons to go from a 0 to a +1. I'm also going to lose 2 electrons because if this is gaining 2 electrons, I have to lose 2 electrons. So then I'm going to have to multiply both sides by 2. And if I'm looking at the same method, so chromium, if I'm just looking at the chromium ions, it goes from a +6 to a +3, which means that I'm reducing my oxidation state by 3. That means I've had to gain 3 electrons. And here, manganese going from a +2 to a +7, it will have to lose 5 electrons. So the least common multiple between 3 and 5 is 15. So I'm going to have to exchange 15 electrons between these in order to have everybody be happy. So for chromium to go from a +6 to a +3, 5 of them will have to do that in order to gain 15 electrons, excuse me. And manganese going from a +2 to a +7 oxidation state, 3 of them will have to lose those 5 electrons to make 3 manganese +7 charge. And then there should be a conservation of charge, right? Because I'm transferring electrons from one side to the other. Overall charge shouldn't change. So 3 times +2 is +6. 5 times +6 is +30. So on this side of my reactants, I have a +36 charge. Here on this side, I have +21, +15. So 21 plus 15 is 36. So these are balanced. If I go back up here, I have a 0 and a 0 in my reactants. And then I have a -2 and a +2 because it's 2 times positive, so 0 as well. So when we're balancing these redox reactions, whether they're simple ones or whether they're more complex, I always need to check to make sure that my charges on both sides balance.